After 1085, Toledo became the center of a massive process of translation of Arabic works into Latin. Scholars frustrated by the restrictions of European learning flooded to Toledo to read for themselves the famed works of the Arab masters. One such scientific masterpiece, which was translated into Latin in Toledo, was given the name De Aspectibus, or the Optics. The early Arabic scientist, Ibn Al-Haytham, was the founding genius of the modern science of optics. The man who first demonstrated the key properties of light.
I can demonstrate this here using this glass tube. You're going to be able to see that the light travels through this tube in a straight line and is escaping here and hitting the screen at this point.
This basic truth, that light travels in straight lines, was first proved by Ibn Al-Haytham. He also established rules of the process we call reflection.
This tube is reflective, so the rail of light is now reflected to hit the other side of the tube here again and again and again, zigzagging its way out. Zigzagging through this tube is exactly what happens to the light inside an optical cable.
Ibn Al-Haytham developed his theory of optics into a holistic vision of how human beings see. He conducted a brilliant experiment to which he gave the name Al-Bayt al-Muthlam, which means dark room, or in Latin, camera obscura.
We have a beautiful view of a nice church just outside the window here. Now, if I close these blinds, through this pinhole I created in this blind, I'll be able to capture an image of this church on this transparent screen. However, it's an inverted image. As Ibn Al-Haytham explained and demonstrated, is that the light reflected from the bell tower of this church is going to travel in a straight line diagonally through the pinhole to hit the bottom of the screen, whereas the light traveling from the bottom of the church is going to reflect and travel in a straight line through the pinhole to hit the top of the screen. If I let this eye look through this pinhole, I'm going to be able to see the image of the church again and invert it back on the retina of this eye.
The brilliance of Ibn Al-Haytham was to see this was the secret to the workings of the human eye. This was due to his unique methodology. By positing a theory, testing it with experiments, then publishing results, Al-Haytham and his colleagues in the Arab world had taken what the Greeks called natural philosophy and changed it into something different, something that was starting to resemble what we call science.